Okay, before we get started on differentiation, we're going to have a very quick review of functions because we're going to use functions a lot in the next few videos. So a function is made up of three parts. We've got a name, we've got an input and an output. And the output of any function depends on the input of that function. So let's say, take this function up here. The function f of x is equal to x plus 1. The way we say that is we say f of x. I'll write that down. We say f of x equals x plus 1. So this is just the way we say in English what I've written in maths up there. So, okay, again, the most important thing about a function is that the output of any function depends on the input. So in this function here, f of x is equal to x plus 1. The input is this part x. And over here it tells us what x can be. It says x is any real number. So x is a real number. So we can put any real number into this function and we get out that real number. The output is that real number plus 1. So let's have a look at a few examples. So say we let the input, we say x is equal to 1. So when the input is 1, which is a real number, the output, we write it like this, f of 1 would equal 1 plus 1. 1 plus 1, which is 2. So when the input is 1, we have it here, the output is 2. So the output depends on the input. When x is equal to 2, we have f of 2, which would be 2 plus 1, and 2 plus 1 is 3. So when the input is 2, the output will be 3. All I'm doing is, whatever the input is, whatever I put here, so when I work out f of 1, I replace the x with 1. When I work out f of 2, I replace the x with 2. And again, if the input is 3, I'll replace the x part with 3. So f of 3 will be 3 plus 1, which is 4. So you can see every time the output of the function 2, 3, and 4 will depend on whatever the input to the function is. And that's all a function is. Very, very simple idea. One other thing that we can do with functions, and I'll show you how to do it now, is we can graph functions. So let's say we take that function again, f of x is equal to x plus 1, and we're going to graph that function to see what it looks like. So to graph the function, we need an axis, an x and an x axis. So we'll take our x-axis here. But we also have an f of x axis. Sometimes that's called, because this is usually the y-axis, sometimes this is called a y equals f of x axis. So that's fine as well. We can have it like that. Okay, let's mark a few points. So we have 1, 2, 3, 4, and let's say on the f of x axis we've got 1, 2, 3, 4, 5. We can put in negative numbers, so minus 1, minus 2, minus 3, and then negative numbers down here. We would have minus 1, minus 2, minus 3, let's say minus 4. Okay, so we want to plot this function f of x is equal to x plus 1, which means we need to find some points on that function. So we can just pick any points, any x values, and find out what is the corresponding f of x value. So let's say when x is equal to 1, we can work out f of 1, which is 1 plus 1. We did this before on the previous page, which is 2. That means the point 1, 2 is on the function, so we can mark that in. So the point 1, 2, out 1 on the x-axis, up to 2 on the y-axis, or the f of x-axis. When x is equal to 2, f of 2 would be 2 plus 1, which is 3. So the point 2, 3 is on the graph, is on this graph x plus 1. So the point 2, 3, out 2 on the x-axis, up to 3 on the f of x-axis. So it's up here. We can fill in negative numbers. So let's say x is equal to minus 1. Then f of minus 1 would equal 2 times minus, or where am I getting that? F of minus 1 would be minus 1 plus 1, which is 0. So that means the point minus 1, 0 is on the graph of this function. So the point minus 1, 0 would be around about here. So this function, f of x is equal to x plus 1, in order to draw it, and I haven't drawn it kind of to scale, I haven't put it, we should get a straight line here. If I'd drawn it completely accurately, if I'd put these points, so drawn the axis accurately, I would get a perfectly straight line. But that's how we plot functions.